computer networks. We define what a network is, and before we got to this stage where we are now, network security, right? So in general, okay, in general, when we are discussing anything that has to do with network security, when we're discussing anything that has to do with network security, you can look at it this way. One, we have devices. Okay, on any network, a network is made up of devices. That's one. And these devices, they contain IP addresses. When we're talking about devices, we're talking about your computer, your phone, whatever is connected to that network. You understand? So your devices contain what we call IP addresses. This same device contain what we call a MAC address. That's on the same network. Okay, so your devices contain IP address, it contains MAC address. Okay, and your devices contain what we call port. This port is very, very important. Okay, and ports on your computer, when we talk about ports are either open port or closed port. Secondly, ports are either filtered or unfiltered. Then these ports are running on an OS, that is operating system, and there are services. Okay, let me not bore you with this. Let's look at it step by step. Okay, let's look at the concept of the networking concept. Devices in the network are identified and managed using IP addresses, MAC addresses, port, and the services or the operating system running on them. Okay, so now let's try to break this down one after the other. First, let's start with what is a computer network. These are things we have done before, but I'm just trying to refresh our mind. Okay, so that we'll be on the same page. Understand? So that when we start doing some things, you don't get confused or start asking, what is this one? What is this one? What's happening? You have more better understanding. You understand? So a computer network is a system. Please, at any point, if you cannot hear me, just drop a message on the Telegram group. That's on the Telegram, so that I will know you cannot hear me. Then if you cannot hear me or you cannot see my screen at any point, please drop a message so that we'll move together. Okay, so a computer network is a system of connected devices that can share resources. One, so for us to say this is a computer network, they must be able to, one, share resources. They must be able to communicate with each other. Okay, and the network allow devices to access shared information, transfer data, and must be able to collaborate. You understand? So those are like the characteristics of a network. Those are the characteristics of a network. Okay, so I mentioned some things earlier. I say devices contain IP addresses and MAC addresses. Okay, they have ports. These ports are either open or closed, or filtered or unfiltered, and these ports are running on an operating system and services. So now let's look at them one after the other. We're starting with the MAC address. Okay, so MAC, MAC, simply means media access control. Okay, is a hardware identifier that uniquely identifies a device on a network. Don't forget, we have already defined what a network is. And in our previous class, I taught you types of network: the LAN, the MAN, we talked about different types of network and the area the network can cover. You understand? We also talked about network topologies and all of that. Okay, so now we're talking about we're trying to see those components, everything that like kind of make that network a network. Okay, so we have MAC addresses. Like I said, MAC addresses, MAC, MAC, the full meaning of MAC, that's MAC, means media access control address. Okay, and it is a hardware identifier that uniquely, that means you can't have two you can't have two devices with the same MAC address on the same network. I come again, you cannot have two devices with the same MAC address on the same network. That's what they mean by unique. So it is a hardware identifier that uniquely identifies a device on a network, and it is assigned by the manufacturer. Okay, it's assigned by the manufacturer of the network interface card, NIC. Now, for any device to be able to connect to a network, it must contain that network interface card. If there is no network interface card on that device, it will not be able to connect to any network. That is why not all electronic devices can connect to a network. You understand? It is only the devices that have network interface card that are able to connect to a network. Talking about things like printer, scanner, your computer, and other devices. So for a device to be able to connect to a network, it must have this network interface card. Okay, so the MAC address is assigned by the manufacturer of the network interface card. To break this a little bit down, now, like your computer, let's say for example like HP, if you're using a HP computer, the network interface card on your HP might have a different manufacturer. It might not be the network interface card might be manufactured by another company, not necessarily HP themselves. If you're using a Dell, the network interface card manufacturer might be a different company, which is not Dell, or maybe you're using a Lenovo. Do you understand now? So this network interface card, there's a company. In fact, not only network interface card, many parts of the computer are manufactured by different companies. Okay, so companies like HP now, that we know to be producers of computers, they get different parts. They don't manufacture all the parts. They get different parts from different companies. Like the processor on your computer, if you check most HP computers, their processor are manufactured by Intel. That's another company on its own that manufactures that particular part of your computer. Okay, screen might be manufactured by another company, the keyboard another company, the motherboard is manufactured by another company. So just like that, different part of your computer. So what HP does is they partner with those people, then assemble this component together and form a computer. I hope we're all getting, we're all following. Just like the same thing with your software. The softwares that runs on your computer are coming from different organizations. Like your Windows is coming from Microsoft. Okay, your word processing is coming from Microsoft. But when you come to things like the graphics softwares, things like Adobe, they are coming from another company. So it's different companies that manufacture various parts of your computer that, when put together, forms your PC. Okay, so we're saying that this MAC address is usually assigned by the manufacturer of the network interface card. So they are the ones that will assign a MAC address number to that network interface card. So if at any point maybe your network interface card have issues and you decide to change it, you might get a different number. So let's proceed. Now the format of a MAC address are usually 48-bit hexadecimal numbers, usually written as something just like what you're seeing on your screen: 00 colon 1A colon 2B colon 3C colon 4D colon 5E. These are like kind of binary numbers. If you don't know much about binary numbers, I will advise you go and study a little bit on binary numbers so that you understand what binary numbers, hexadecimal numbers, what all of that really means. Okay, and what is the purpose of MAC address? MAC address operate at the data link layer. Data link layer is the layer 2 of the OSI model. These are things we have studied in the past. We studied the OSI model and we looked at each of the layers and what they do. So the MAC address operate at the link layer, which is the layer 2 of the OSI model, and it is used for communication within the same local network. I'll come again. It is used for communication within the same local network. Okay, that means you cannot use your MAC address for communication outside that local network. Okay, once it comes to communication outside a local network, that's when we now begin to talk about IP addresses. Okay, so what are the key points here? MAC addresses do not change, they are permanent. Like when a network interface card comes with a MAC address, that MAC address remains on that network interface card forever. Okay, except maybe you change, and even if you change it, the one you put is the same. Every network interface card have a permanent media access control address on it, and it does not change. Okay, and MAC addresses are used by switches for data delivery within the same network. We are still saying the same thing, within the same local network, that is the LAN. Let's proceed. So this is what MAC address looks like, just like what I just demonstrated in the previous screen. This is what it looks like. Okay, so the first 3 hexadecimal numbers represent the organizationally unique identifier, while the remaining 3 hexadecimal numbers represent the network interface controller specifics. Okay, so the second component we are looking at is the IP address. Please, I want us to, we really need to understand this, because this is what will form the basics for whatever we'll be doing subsequently, be it network scanning, vulnerability scanning. This is going to be the basics of whatever we'll be doing subsequently. You understand? Okay. So now we're looking at IP addresses. These are things we have already seen earlier, but I'm just trying to explain it again so that we get it better. Okay, an IP address is a logical identifier. Now when we say logical, that means it is not like a kind of hardware, unlike the MAC address. You understand? This is logical. It's a number that you assign, okay, or it can be automatically assigned based on the configuration that you put into the system. So an IP address is a logical identifier for a device on a network used for communication across different networks. I hope this is getting clearer now for most of us. I know in our previous lecture I did not explain it in more details like this, so I'm just trying to make it more understandable for us so that we get this foundation. If this foundation is not very clear, subsequent lessons you might find it challenging. Now we have two types of IP addresses, just like we mentioned in our previous lesson. We have the 32-bit address, that's the IP version 4, which is the 32-bit address written as this is just an example, 192.168.1.1, and we have the IP version 6, which is the 128-bit address, and it is written as you can see on the screen. So what is the purpose of this? This operates at the network layer, which is the layer 3, and is used by routers to direct traffic between networks. It is used by routers to direct traffic between networks. Okay, so what are the key points here? An IP address can change. It can be dynamic or can be fixed, depending on the configuration you do on your network. Depending on the kind of configuration you do on your network, IP address can be dynamic or it can be static. I just hope we are following. Now let me tell us what we are trying to address by studying this component, the MAC, the IP address, the port, and all of that. Have you ever wondered what happens when there are like 1,000 devices? I'm even talking about 1,000, like 1,000,000 or even billion devices. But when you send a message to a particular device, you discover that that message goes only to that device. You understand? Even though we have a lot of devices, but when you send a message, it goes only to that particular device. It does not miss, maybe, and go and drop. You're sending a message to a device A, it does not miss, and the message does not miss and go to device B. So MAC address, IP address, and port is what explains why a message that you send does not get conflicted on the way. Okay? Or maybe you send something like a video, and maybe a part of the video does not go and drop in device A, and another part of the video will go and drop in device B. So all of that can be explained with MAC address, IP address, and port. Those are the things that control communication on a network. You understand? They are the things that will tell a particular device or the network that this message is meant for this particular device. is meant for this particular MAC address, and this message is supposed to use this particular port to travel. It's supposed to use this particular port. It is this type of message. This message is a video, so it's supposed to use this this particular port. This message is text, so it's supposed to use this particular port. This message is an internet message, so it's supposed to use this particular port combined with this other port in order to deliver the message accurately. Let's carry on. So this is what an IP address looks like. Okay, so each of the section is 8-bit. 8-bit makes 1 byte. Each section is 8-bit. Okay, in binary numbers, 8-bit is equal to 1 byte. Okay, so an IP address is basically 4 byte. That's what we refer to as the 32-bit, because if you divide 32-bit into 4, each will have 8-bit, 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 8-bit. Combining all of this, it gives you 32-bit, right? And in binary numbers, like I said, 8-bit is equal to 1 byte. So an IP address is simply a 4 byte in terms of size. Now let's look at port. You know, I've been talking about port. So I just hope somebody was not thinking it's a pot they're using to cook. Okay, so a port is a virtual communication endpoint that allows specific services or applications to communicate over a network. Now, what this simply means is that it is the port that determines how a particular type of message will travel. You know, when we talk about sharing messages on a network, messages can be either text, it can be either audio, it can be video, and I think at times it's combination of both text, video, and audio, or combination of audio and video. So now when you send a message, it is the type of message that will prompt your operating system. That's why operating system was mentioned in this context. It is the type of message you are sending that will prompt your operating system to know, okay, this type of message is a video. So what kind of port does it need? The operating system will decide, okay, it's supposed to use this kind of port. Now, who is this message going to? They will check the person's IP address. Is it on the same network? If it's on the same network, they check the person's MAC address. So this information, these processes happen as fast as possible, and so it looks like nothing is really happening, but a lot happens when you send a message on a network. A lot happens. Okay, there are a lot of conversions. Okay, we're still going to look at what we call DNS. That's domain name system. We're still going to look at that. What happens when you go to the internet and you type a website, maybe google.com, whatever website you're typing. I just hope we are following and we understand what I'm saying. A port is a virtual communication endpoint that allows specific services or applications to communicate over a network. Now, ports have range, okay? And ports are numbered from range 1 to 65,535. That means we have, that means on in terms of communication, computer networks, we have up to 65,535 ports, and each of these ports have their own function. They have what the type of message they transmit. Okay, but there are some ports that are very popular. Those are the ports that we use very often, so they are kind of very popular. You get? So we are going to study most of those ports. Now, why are we studying this port? For somebody to be able to hack your computer, hack your message, steal information, it is based on this port. Okay? If on your computer a particular port is open and it is not supposed to be open, then a hacker can easily access your computer through that port and steal whatever the person needs to steal and disappear with it. So you'll be wondering, when they say somebody hacking, when they say they hack somebody's computer, when they say they stole information, when they say this happened, how did it happen? It's because a particular port on your system was left open and it was not supposed to be open. So now you understand why I'm trying to break down all these things. MAC, IP, port. You get? So like I said, port range from 1 to 65,535, which means we have about 65,535 port. Okay? So the well-known ports are from the range of 1 to 1,023. Then we have some ports that are reserved for system services, e.g. the HTTP. For those of you that browse or are familiar with network and hosting and all of that, you know what HTTP is. You know what HTTPS is. Okay? So the HTTP is port 80, HTTPS is 443, FTP is 21. Okay? Please, I would like somebody to tell us the full meaning of HTTP and the full meaning of FTP. Just type the answer in. Just type the answer in on the chat. Somebody is typing the full meaning of HTTP. File transfer protocol. I asked for HTTP. Somebody is typing FTP. Okay, it's all good. Hypertext transfer protocol. Fine. Inone and Abdullah, you are both correct. Now, if you see a website that is carrying HTTP, that means that website, that domain name, okay, for the sake of this lesson, I will be calling it domain name, okay? That domain is not secure. If you see a domain that is HTTP, that domain is not secure. A domain that carries HTTPS, that is a domain that is secured. Okay? HTTPS means the domain is secured. That S means secure shell. We are going to look at that as we proceed. That S has its own port as well. Okay? Now, FTP, why you need this FTP protocol is because normally when you communicate, most of the times you are transferring file, and this protocol is the protocol that is responsible for file transfer. Okay, so you are sending video, you are sending an image, you are sending audio, you are sending text. This is the protocol that is responsible for that transfer. Now imagine that this port is left open. You can know what will happen. Okay, so port, we have registered port range 1024 to 49. 1051. These ports are assigned to user applications, and we have the dynamic, or otherwise known as private port, which range from 49,152 to 65,535. These ports are temporarily assigned for client-side communications. Okay, we'll explain this more as we continue. So we're still talking about sorry, we're still talking about port. Okay, so we have what we call protocol. That's in terms of sharing information. We have the TCP. We have talked about the FTP. We have the TCP, transmission control protocol. This protocol ensures that the communication is reliable. It checks for errors. That's why at times, for most of you that have tried to download one or two things, maybe movies, or you try to download softwares, at times you discover that it will download to a certain level, and at times it gives you error. It will tell you unable to complete download, or it will just give you one stupid error like that. Okay, it is because of TCP, transmission control protocol. If there were no transmission control protocol, you will not get that error. You will think your file has downloaded until maybe you try to use it, and at the end of the day, maybe like a video now, by the time you try to play it, it could play for the first minute, it will get to one point, it start cracking, or it get knocked out. Or if it's a software, maybe when you try to install it, I believe most of you even had these issues when you try to install your VMware and your Kali Linux. Maybe the thing did not download complete. When you try to install it, you'll start seeing some errors. Okay, so we have okay, I believe you cannot hear me at the moment. There's a network break. Yeah, you can hear me now. So let's carry on. So we also have the user datagram protocol. Okay, this particular protocol, UDP, is for fast communication. Network is a little bit breaking, that's why I'm pausing. So UDP is for fast communication, especially on networks that don't really need reliability checks. Okay, for example, live streaming. Okay, a network is breaking a little bit. So if you discover when you're doing live streaming, at times it could get to a point in the live streaming you will only be hearing the audio, and you will not be hearing the video. You will not be seeing you will not see what is happening on the video. Okay, at a particular point on your live streaming, you only hear the audio. You will not see what is happening on the video. Or at times it could be the audio will break, and you only be seeing the video without hearing oh, network is bad. Okay, so the key point in this place is a port represents an entry point for a service, e.g. IP. That's port like 192.168.1.1. Okay, Inonne is typing. I think the network is breaking, right? Yeah, the network is breaking. The network is breaking. It's breaking. Okay. So let's talk about port state. Port state. You know, when we talk about state, for those of you that did sciences, you know there's what we call state of matter. Maybe when something is solid, liquid, or gas. Okay. Okay. So, like I was saying, for those of you that did sciences, there's a point when something is solid, liquid, or gas. So, we talked about the state of matter, right? So, also in port, we have state. So, a port is either open or closed. That's state 1. Okay, so when we say a port is open, that means the port is active and listening for connections, e.g., a web server running on port 80. What did we say is on port 80 again? HTTP, right? Oh, damn it. Network. Oh. Okay. So, port. So, ports are either open or closed. For an open port, the port is active and listening for connection. For example, on a web server running on port 80. Port 80 is the HTTP, okay, which signifies an unsecure web website or stuff like that. Then we have the port can either be closed, okay, the port is not in use but can respond to connection requests. The second state for port the port can either be filtered, okay, that's to say the port is protected by a firewall. That's all just now. So when we say a port is filtered, that means it's either protected by a firewall and packets are blocked or monitored. That means unwanted packets are blocked and only the ones that need to pass through the network are allowed. Okay. Then we have unfiltered port. This kind of port allows anything. The port responds to requests but may not reveal whether it is open or closed. This kind of port is just anyhow. Okay. So the key point to note here is that open ports are potential security risks if services are misconfigured. Open ports are potential security risks if services are misconfigured. Now let's talk about operating systems and the services on the port. This network. Ooh. Okay, so sorry about the network. Okay, Abdullah is raising his hand. Abdullah, you can speak. Abdullah, you can speak.
Yes, sir.
Okay. You are raising your hand. You can speak. Man, this network is really just messing up things.
Yes, sir.
Can you just drop your message on the comment? Network is a little bit very
All
poor
right.
at the moment. Just drop your message in the comment, then I'll look at it.
All right.
Abdullah, I can't see your message. Um, uh, Sorry everyone, the network is a little bit very poor. I don't know if it's from my end or what. I think it's from my end. The network is a little bit poor. So I think we'll just stop here for tonight. Then tomorrow. Okay, so yesterday before the network uh, got messy, we stopped at operating system and services. We are talking about IP addresses, MAC addresses, and port. Okay, so the operating system is the system software that runs on a device like on your system, like on your computer. Without the operating system, your computer is kind of like useless, right? It is the operating system that makes a lot of decisions. It is the operating system that communicates with like your hardware. It stands in between. It stands in between your hardware and the other applications that are running on your system. Okay, so like yesterday, I was trying to tell you how when you send information, that depending on the type of information, there's a particular port that it follows uh, in order to deliver that information. Okay, so the only way your system knows that this particular information is supposed to be on this particular port is because of the operating system. Understand? Because it's the operating system that manages the communication. When the operating system reads a particular information, if it's video, it knows, okay, this kind of information is supposed to follow this channel. If it is um, audio, text, and all of that, it knows this is where the information is supposed to follow, right? So, just like we said yesterday, we have some ports that are common, and we talked about HTTP, uh, secure remote login, that's the SSH, secure shell, port 53, DNS. We'll look at DNS shortly as well. Okay, so the role of the operating system is it manages the assignment and operation of services on specific port, ensuring smooth communication. So misconfigured services on open port can expose vulnerabilities on your system. So it can cause someone to easily hack your system. So that's one of the reasons why you see things like Windows now, the Windows operating system, right? You see they keep, like, maybe every 3 years, every 4 years, 5 years, they will bring a new operating system. They started from Windows 20, Windows 92, Windows 93, like that. We have Windows 2003, Windows 2005, Windows 2007, 2010. I think we also have Windows 8, Windows 10. Then I think the current one now is Windows 11. So the reason they keep releasing this is because they discovered maybe some vulnerabilities on the previous Windows. They discovered some ports that were misconfigured. So they will release a new Windows that have closed that particular port. So that's why we keep having new versions of Windows coming out, like almost every year. So on the screen we have some common ports. These are the ones that we'll be looking at, we'll be using very often. Okay, so we have port number 20 for FTP, that's File Transfer Protocol. That's the process name. Protocol that it uses is TCP. For file transfer, we have port 21, also FTP. We have port 22, Secure Shell SSH. We have port 23, Telnet, that's telephone network. We have port 25, SMTP, that's Simple Mail Transfer Protocol. We have port 53, DNS, Domain Name System, port 69, port 80, port 110 for port 3, Post Office Protocol. This is also for mail. Okay, so we have NTP, IMAP, Internet Message Access Protocol. All of these are for mail. HTTPS, secure implementation of HTTP. So HTTPS is 443. I want us to take note of this particular one, HTTPS and HTTP, port 80 and port 443. Very important. Port 80 and port 443, because those are very common ports that we'll be looking at, like, very often. Okay. So in summary, a device is identified by its MAC address on a local network and its IP address for broader network communication. The device communicates via port, which are endpoints for specific services. Just like I said, depending on the type of data you're sending. So the port are endpoint for specific services or applications. Ports are either open, closed, filtered, or unfiltered. We discussed all of this yesterday, so this is just a summary. So depending on the firewall rules that you set, that the way you configure your firewall, that's what will determine if your port will be closed, open, filtered, or unfiltered. Okay. The operating system ensures the proper functioning of these services and secures the communication. So let's look at a scenario. This is like a scenario that what happens. All of these things we have been saying, like, let's look at a particular scenario and see what really happens. So a user visit a website, when you visit a website, you use your browser, right? So the application you're using is a browser. Now on your browser, you're going to type the name of the website. Okay, so a user visit a website, their device identified by the MAC address sends a request to the router. Okay, because if uh, your router is not working or you don't have network on your device, there's no way you'll be able to access that particular website. So that's the first thing that uh, your MAC address checks. Then the router forwards the request using IP address of the website. Okay, we're going to look at this shortly. Your website, all those things you enter, www.google.com, www. Maybe which other website, facebook.com. Your computer really does not understand all those things, so it has to convert it to IP address, and further your IP address is further converted to binary numbers, just like we have seen in our previous lesson. So the router forward the request using IP address of the website. Okay, I'm going to show you in Kali how you can check the IP address of a website, and how you can also check a website using an IP address. Okay. So the web server listens on port 80. So if I say port 80, you already know we're talking about HTTP, and responds with the request data. The communication is managed by these two protocols, TCP or the UDP. Okay, we talked about this yesterday, the TCP and the UDP, and secured by the operating system. Okay, so understanding this relationship is very critical for both networking and cybersecurity practices. So this is just like a scenario of what happens when you try to access a website. It could be any other service apart from accessing a website. So finally, let's look at domain name system. Okay, the most of the time what you see is just DNS. It simply means domain name system. Domain name system is a fundamental system of the internet that translates human readable domain names. That's all those websites you type on the browser, www.this, www.this. So it translates those human readable names into machine readable IP addresses. Like I said, your machine, which in this case your computer, does not really understand all this English that we were reading. When you type www, your machine does not understand that. So the DNS, domain name system, convert this. It translates this human readable name into IP address so that the machine can read and understand. Okay, I understand this. So it acts as a directory, or like a phone book for the internet. Understand? So like for every website that is hosted online, that's registered online, their IP addresses are stored somewhere, like on a phone book. So when you type, it searches for that and then gives feedback to the machine. So why is DNS important? Why is it important? When you enter a domain name such as www.google.com in your browser, the browser does not understand domain names. Okay, it does not understand this English. Okay, so it needs the IP address of that www.google.com. It needs the IP address of that domain to locate the server that is hosting the website. Okay, so I hope you all know that every website is hosted on a server. No matter what kind of website. Okay, these are things you can always study on your own. It will also help you try to read how a website are hosted online. Every website is hosted on a server. Like there are private companies and there are organizations that uh, set up servers, and then they can be giving out services for people who want to host their website online. So every website is hosted on a server. Okay, so when you type your domain name on the browser does not understand the domain name, so it needs the IP address. For example, 172.217.160.142 to locate the server that is hosting that website. Okay, so after locating it, the domain name system resolves this by converting the domain name into its corresponding IP address, thereby enabling communication, because the machine only understands machine language, right? So how DNS works? DNS follows a hierarchical structure and operates through the following steps. Step 1, query submission. Okay, so a user will type, or when you enter your browser, you are the user, you enter your browser, you type www.example.com into your browser. So the browser will send your domain name system query to the domain name system resolver. Okay, so step 2 is the what we call the recursive resolution, where the domain name resolver follows these steps. Root server, it queries one of 13 root servers that's globally distributed for the top level domain. In short, is known as TLD. For example, we have .com. We also have things like .org, uh, .com, .ng, .net. There are a lot of all those uh, top level domain. Okay, those TLDs. Okay, so the TLD server, which is the root server, directs the resolver to the TLD server responsible for the .com. The .com we are using in this context now is just an example. It could be a .org. Okay, I hope you follow. So authoritatively, authoritative name server, that's the TLD server, directs the resolver to the authoritative name server for the example.com, which is what we typed on the on the browser. Then IP address resolution, the authoritative name server provides the IP address for example.com. It fetches it out so that the machine can now understand. Then step 3, that's when you now get response. Okay, the resolver sends the IP address back to the browser, and the browser connects to the server hosting the website using provided IP address. That's when the website will now open for you. Okay, that's what happens when you type a website. You see, it takes some times. It takes time to load. In that process, where your website is loading, it is going through all these processes, trying to get the IP address, know where the website is hosted, trying to make sure there's a communication between your computer and that server. And that communication can only happen through IP address, because your computer and even the server where the website is hosted, they don't understand English, they only communicate with their IP address. Okay. So that will be all. Let me launch my Kali. If you are with your Kali, you can also launch, so that okay, power this virtual machine. For those of you who still don't know how Kali works, this is how it works. When you launch it, you power the virtual machine and you wait for it to load. I think we're going to do I'll do another class just explaining the Kali interface to us, so that at least we'll grab the basics. We're going to do a class. I think our next week class should be on that. Okay. Kali mostly works with command line, like it's a kind of coding. You have to be, everything here works with code, so that's how Kali works. So I'm just waiting for the Kali to load. I believe you can all see my screen, right? Can you all see my screen? Just type yes in the QA. Let it not be that I'm alone here. Okay. Only Abdullah and Kingsley can see my screen. No, Ugochukwu, Aduru. Okay, that's fine. So let's fire on. So this is my interface. I'll enter my username and then my password. So the Kali is kind of like a very heavy software, so it takes time to load. Okay, so you just have to be patient. Okay, so this is what the Kali looks like. For those of us who are still a little bit confused about Kali, now Kali, okay, Kali is like a computer. This is another computer on its own that is running on your computer. So when you open your Kali, see it as you have opened another computer entirely. This is another operating system running on your machine, right? If you even check like my time, if you look at just follow my cursor, top right, you can see those stuff like wavelength. Okay, that's is showing you that my operating system is up and running. Those are the frequencies. Okay, so you can see all those normal stuff that you will see on your Windows. When you open your Windows, those things you will see down at the bottom left, they are also here, but at the top left, the speaker, all those mute, battery level, time. And if you check my time, is the time here is showing 1:30 something, because this Kali now is not reading Nigerian time. Okay, anything I'm doing on this Kali now is as if I'm doing it from the US. This time you are seeing here now is from the US. This is a US time. So the time in their time now is 1:33 p.m. It's 13:1, yes. Okay, so this environment, this is my desktop. Okay, this environment is my desktop. This thing that you are seeing like a dragon, you can change that desktop background if you don't like it. We are going to look at all of that in our next class. I'll show you how to create folder, delete folder, how to download applications. Okay, you can see it comes with its own browser. This Firefox, this thing that looks like Firefox ESR, that's its own browser that it comes with. Okay, then like I said, everything here is kind of coding. Don't worry, next week we'll look at how this functions. These are my basic folders, just like on your normal Windows, where you have the desktop, document, download, music, pictures, videos, and all of that. Then if you want to create your own folder, you can also create it. We're going to look at all of this using command line, how to use the CMD, right? We'll check all of this next week. Then if you want to open any application, just go up. I believe you can see my mouse moving. Can you see? You can see my mouse moving, right? So if you want to open any application that's on your Kali, you go to this top left where you have that dragon logo. You see application, just click on it. You can see list of applications here, different lists of application, information gathering, vulnerability analysis, web application analysis, database assessment, password attacks, wireless attacks, reverse engineering, exploitation tools. We have sniffing and spoofing tools, post exploitation, forensics, reporting. So a lot of tools, and if you don't have time to start searching them one by one, if you know the name, you can just come here and search for it. Okay, like Nmap now. Once you type it, it will come up. Or let's say you want to open like Wireshark, you just type Wireshark, it will come up. Okay, but if you want to start searching one after the other, you can just move across the applications one after the other. Then when you see the application you're looking for, you click on it and it opens. Okay, then by default we have close to the browser, this Firefox browser, if you check, you see that black stuff, this terminal emulator. Okay, so that's what we'll be using mostly, this terminal emulator. This is what we'll be using mostly. Okay, so for those of us who have not been serious, this is where you should get serious, because we are going to start doing some stuff that might look like magic. So please let's pay attention. I believe you can all see my screen, right? Please, at any point you cannot see my screen, just indicate so that I will know you can no longer see my screen.